Good morning everyone. Good morning sa mga civil engineering students na nanonood ng aking video, no? So for today's video presentation, I will be discussing PCSP 411 Professional Course Specialized Program Foundation and Retaining Wall Design. So this subject is intended for my students na kung saan is nagte-take ng specialized program, which is the structural engineering, no? Yun yung majoring nila. So for today's video, let's have the overview of this presentation, no? So topic overview, we have here the first topic, which is the introduction. So under that introduction, I will be discussing the NSCP 2015 provisions, no, yung under earthwork, foundation, and footing. For the second topic naman, I will be discussing the definition of footing and foundation, as well as the different types of foundation, no. For topic 3, I will be discussing the design concepts as well as the design consideration to be used when designing a foundation or a footing, no? As well as dyan sa topic 3, kasama na po dyan yung mga sample problems, no, in applying those concepts and considerations kapag tayo nag-design. Okay? So let's summarize the design procedure of our foundation, no? So the following design procedure can be used in designing the footing. Included is the information presented in the previous section of analysis, design, and detailing. So first, step 1 natin is to determine the area of the footing. So kapag tayo nagde-design, unang-unang hahanapin natin is yung area ng pundasyon natin. Pangalawa is yung thickness of the footing by shearing stress, one-way and two-way shear. Then pangatlong step natin is flexure and steel reinforcement, no? So just sa step 1 to 3 is nakapag-design na tayo ng maayos niyan, no? Then step 4 is the developmental length of the reinforcement, no? Doon sa mga ipe-present kong sample, hanggang step 3 lang muna tayo, no? But I will be giving sample din ng may developmental length. Okay? So I do hope na wala pa namang questions, no? At nagigets pa ninyo. Okay, so ito is isa-summarize ko lang din yung mga formulas na kailangan nyo din tandaan, no? Ipe-present ko lang din siya. Kapag tayo ay nagde-determine ng area ng footing, so we have the formula QA is equivalent kay force all over area, no? So, yung given allowable soil bearing capacity plus yung given unfactored load, so makakapag-compute ka ng area, no? So, the area is equivalent kay B squared for square footing and B times L for the rectangular footing. So, dito, mako-compute mo yung area, then makakapag-assume ka pa lang ng thickness ng footing. So, after mo mag-get yung area, maka-compute ka ng B or L. So, you could use this formula, HC or height of concrete is equivalent kay 20% of the longest side, longest dimension plus 75 mm to get the value of thickness of, assumed thickness of the footing. Then, for getting the effective, kasi kailangan natin yung effective bago tayo makakuha ng actual area. So, si effective Q natin is equivalent kay allowable minus yung stress na induced ng soil minus stress ng induced ng concrete. Tapos kung may mga ibang stresses pa dyan or pressure na ikikiri yung ating pundasyon, ilalagay nyo din po dyan, no? Okay? Then, after mo mag-get yung QE is equivalent kay force ulit over area, no? Then, after mo makuha yung area dito, ito na mismo yung actual dimension ng footing natin. Dito sa part na to, no? Makakuha mo yung area. Okay? Then, for the step 2 naman, ito yung mga formula na kailangan natin. After mo makuha yung area, so kailangan mong i-get yung ultimate soil pressure, yung QU. But, using the factored force na, yung may 1.2 and 1.6 live load. Divided by the area computed dun sa previous steps natin. Okay, after mo makompute yung QU, then i-check mo yung one-way and two-way shear to get the value of D, no? Or the actual thickness. Yung kinompute nating HC kanina is ano lang yon. Assumed thickness lang yon to get the thickness of the footing para dun sa pagkuha ng QE. But hindi yun yung actual natin. So dito siya makakuha gamit yung one-way shear and two-way shear. So the formula is the same. VU is equivalent kay VBC, but the value of VU is QU area shaded. Yung area shaded po dyan is yung critical section kaninang sinabi ko na kapag one-way shear is distance D from the face of the column, then ito, BWD is yung, basta papakita ko yan sa example, no? Then kapag two-way naman, yung area shaded naman natin is yung sa may malaking part, no, na pinunch. Then the formula is, pakitandaan na lang po, 0.33 lambda the square root of F prime C BOD for the two-way shear. Then for the one-way ay phi times 0.7 lambda the square root of F prime C BWD. Okay? So, mas matatandaan nyo naman yan kapag tayo nag-sample problems na. For the step 3, which is the flexure and steel reinforcement, or the steel requirements of the foundation, we have the formula mu is equivalent kay phi RUBD squared. Okay? Then after, si mu is the, ano lang din yan, yung gamit yung QU. No? Makukompute natin dyan is yung RU. Then the RU is used in this formula to get the value of rho. No? Then after mo makuha yung rho, check mo muna siya sa rho minimum. Kapag yung rho is greater than rho minimum, use this computed rho. But if this rho is less than rho minimum, use this rho minimum as your rho, or the ratio of your concrete and your steel to get the value of area steel, which is ito. Area steel is equivalent kay rho BD. But yung rho dito is depende, no? Either ito or itong rho minimum. Okay? Then, after mo makuha yung area steel requirements, so to get the number of bars, so we have here AS over area of the bar. Then, spacing of bars, so we have here B, or the length of the footing, minus 150. So, kabilaan kasi 75 mm, 75 mm, so we have here 150 na minus. All over, number of bars minus 1 to get the spacing ng ating reinforcement. Okay? So, sample problems tayo para mas maintindihan ninyo yung ating discussion. Okay? Okay, so we have here a square column footing is to support a 400 mm by 400 mm squared tied column with 12 pieces of 25 mm bar. The top of the footing is located 1.5 meter below the natural grade line. The column is to carry a service dead load of 1,500 kN and a live load of 1,000 kN. Allowable soil pressure is 300 kPa as per boring test conducted by the geotechnical engineer. Also, soil unit weight is determined to be 17.95 kN per meter cube. The site location is determined to be flood-prone area, and there is always an average surcharge pressure of 25 kN per meter squared. Assume that the concrete unit weight of for both column and footing is 23.5 kN per meter cube. Also, concrete cover is located 75 mm from the nearest face of the reinforcement bar. Then design the square footing having 25 mm bar. Assume F prime C is 27.5 and Fy which is 275 MPa. Okay. So kapag tayo ay nagko-compute or nagde-design ng ating structure, kailangan na intindihan natin ng maayos yung ating problem. Kapag wala siyang figure, kailangan mo siyang i-drawing ng maayos, no? So, ito. So, kung may drawing ka ng iyong pundasyon, okay, so kung may drawing ka ng iyong pundasyon, you can identify the given parts ng ano natin, no? So, we have here given yung dead load and live load. So, I can say na itong red arrow down is the force. No? So, pwede natin siya i-detail as ganito. Meron akong dead load, which is equivalent kay 1,500 kN. Then, meron akong live load, which is equivalent kay 1,000 kN. Newton. Medyo malabo ata sa video. No, but I do hope na nakikita niyo siya. Okay, so then, given din na yung depth of yung location ng ating pundasyon is 1.5 meters below the natural grade line. So sabi, the top of the footing. So ibig sabihin yung top ng pundasyon natin ito, papunta sa natural grade line, which is ito nandito. The dimension will be 1.5 meters. Okay? Yun. Medyo malinaw na. So, then, ito is si B, or yung dimension na kailangan natin. So, kailangan, kapag tayo ay nagko-compute, is marunong kang yun nga, sabi ko nga, kailangan marunong kang intindihin yung problem. Marunong mong intindihan yan, no? Okay. Then, we have also the dimension of our footing, which is equivalent kay 400 mm by 400 mm. No? Also, given sa atin is yung unit weight of soil. We have here unit weight of soil, which is equivalent kay 17.95 kilonewton per meter cube. We have here sa concrete, unit weight of concrete, which is 23.5 kilonewton per meter cube. Then we have here QA, which is allowable, which is 300 kPa. Ano pa ba yung mga given? We have also F'C and Fy. F'C, which is 27 MPa, and Fy, which is 275 MPa. Okay? So, ito yan. So, actually may figure siya, no? Pero hindi ko siya, usually kapag nagpapa-exam ako, hindi ko nilalagyan ng figure. I want my student to draw their own figure, no? Okay, so yan. Balik tayo dito. So, at least, na-drawing mo ng maayos yung ano natin, no? Then, sabi daw, may 75 mm concrete cover from the nearest reinforcing steel bar. So, we have here, this one to this one, may 75 mm ako. Na, after mo ma-drawing yung mailagay yung mga values ng iyong problem, pwede ka na mag-compute, no? Pero kung di mo matandaan, kung during exam yan, hindi mo matandaan yung formulas, at least, wala ka man lang may sagot, may drawing ka naman, no? Malay mo, maawa yung prof, bigyan ka ng points or ng bonus points. Okay? So, let's continue, no? So, solve na natin. So, lahat ng dyan na yan, no? So, we have here solution for number 1. Check natin, ha? Solution for number 1. So, we have here the formula given as Q allowable is equivalent kay force all over area. Tama? Which is equivalent kay yung QA natin, which is 300. Ingay ng mga aso sa kabila. No? We have here QA, which is 300. Lagay ko na lang, ha? Dito. 300 is equivalent kay P over A. Si P is 1.5 plus yung 1,000. 1,500 plus 1,000 all over the area. The area is, since square ang pinag-uusapan natin, we have here B squared, no? B squared ko na lang ilalagay. Then we could compute that P is equivalent kay square root ng 1.5 plus 1,000 all over 300. So we could say that 2.8868 meters yung dimension natin, no? Yan ay yung assumed dimension pa lang. Then, we could get the assumed thickness using the formula HC is equivalent kay 20% of the B plus 75 mm. Okay? So, we have here HC, which is equivalent kay 0.20 multiplied by B, which is 2,886.6 plus 75 mm. Okay, take note na yung na-compute mong B dito is naka-meters and take note na yung 75 mm mo dito is naka-mm. So, kailangan naka-millimeter din po yung ano natin, B dito. Para pag kinumpute mo is lahat yon is uniform yung ating units. No? So, we have here HC which is equivalent kay 0.20 times 2886.6 plus 75. So, we have here 652 652.32 mm. Okay. After mo makuha yung 652.32 mm, we could get the value of QE, no? Dun sa formula pinakita ko sa inyo. QE is equivalent kay Q allowable minus unit weight of soil, height ng soil, minus unit weight of concrete, H concrete, minus pressure kung sakaling may pressure. Di ba? Pressure. Okay, so based dun sa given natin, may pressure tayo na 25 mm, no? We have surcharge pressure, 25 kilonewton per meter squared. Okay, so pwede na natin computein yan, no? So, yung allowable soil pressure natin minus yung unit weight times height ng concrete, height ng soil natin, tapos yung unit weight tapos yung height ng concrete natin. Ito 'yon, no? Yung height nito plus height nito minus nun para makuha natin yung actual pressure na effective dito sa ating ilalim, no? Okay, to get the value of QE, we have here 300 which is QA minus soil unit weight which is 17.95 multiplied by HC height ng soil which is 1.5 minus unit weight of concrete which is 23.5 times height ng concrete which is 0.65232. Take note na ito ay naka kPa, so kilonewton per meter squared, no? Then alam mong itong kilonewton per meter cube to, kailangan mong mag-multiply ng meter squared, meter dito sa taas, no? Same din dito, kung ito ay kilonewton per meter cube, so kailangan naka-meter po itong height natin. So the height which is naka-mm dito is meter ko lang, no? Minus 25 which is the surcharge pressure. Okay? Then we have here QE is equivalent kay 300 minus 17.95 times 1.5 minus 23.5 times 0.65232 minus 25. So we have here 232.75. 232.7455 kPa. Okay? So, pinor decimal places ko kasi naka 4 decimal tayo dun sa una. No? So, para uniform yung sagot natin. Okay? So, after natin makuha yung QE, so, susolve na natin yung actual dimension ng footing. No? So, we have here QE is equivalent kay force all over area ulit tayo, which is equivalent kay 232.7455 is equivalent kay 1,500 plus 1,000 divided by B squared. So, the actual dimension, which is B, is equivalent kay square root of 15 plus 1,000 divided by 232.7455. So, we have here 3.2774 meter. So, since ito na yung final natin, dimension, we could say that, say, B is equivalent kay 3.3 meters, 3.3 meters by 3.3 meters. Okay? So, yan. This will be our dimension of the footing, no? Yung base, yung length and width ng ating pundasyon. But yan ay ano pa lang tayo. Step 1 pa lang po tayo, no? Okay. So after natin makuha tong step 1, di ba mag-step 2 tayo? The step 2 is getting the value of QU and as well as yung QU is to be used dun sa ating one-way and two-way shear. Okay? So, dito na lang din ako mag-solve, no? Getting the value of QU which is equivalent kay factored force P all over area. Okay? So, we have here factored force which is 1.2 dead load. 1.2 times 1.5 plus 1.6 times 1,000 all over the area which is the computed ito. Ito na mismo yung rounded off na. No? 3.3 times 3.3. The value of QU is equivalent kay 1.2 times 1.5 plus 1.6 times 1,000 all over 3.3 times 3.3. So we have here 312.2130 kPa. Okay? So, yan na yung QU natin na. Pakatandaan po yung QU. Okay, next tayo. Hindi na magkasya sa board eh. So, we have here checking for one-way and two-way shear. Okay? So, let's have one-way shear. Medyo malabo. Wait lang. One-way shear. Okay, so sa one-way shear, the formula will be VU is equivalent kay VC, and we all know that VU is QU area shaded. QU area shaded is equivalent kay phi times 0.17 lambda the square root of F prime C BWD. Okay. Balik lang ako sa PowerPoint presentation. So, the critical section, as you can see in the video, itong critical section natin to, wait lang, kita pa ba? The critical section for the one-way is itong nanditong part na to, and the critical section for the two-way is itong part na nandito, no? Ito? Itong part na nandito. Tapos itong nandito yung two-way. So, in getting the QU area shaded is itong part na to. Ito yung area shaded natin. Yun yung kailangan nating hanapin, no? Then, yung BW yan is itong BW to. Tapos yung D is yung thickness, no? Okay? So, balik tayo sa dating problem. Okay. Balik tayo sa solving. So, we have here QU area shaded. The value of QU is equivalent kay 312.2130. Paki-take note na ito ay naka-KPA. Okay? So, if kailangan kasi uniform yung units natin, no? Paki-take note lang na ito ay naka-KPA, no? Okay, multiplied by area shaded. The area shaded is yung kanina pinakita ko, which is equivalent yan kay 3,000. Since lahat ay dapat naka-MPa na to para lahat ng value natin is naka-mm. Okay? So, basta ito, take note lang na naka-KPA siya kanina. 3,300 minus the dimension, ito, balik na tayo. Di ba ito is 3,300 din to. So, to get the value is 400 all over 2 para makuha yung center yung C natin, para makuha yung C, yung center, minus D times B W, which is equivalent kay 3,300 yan. 3,300. Okay? Ito po yung QU area shaded. Okay? So, yung makikita nyo nung 3,300 minus 400 over 2 is ito yon, yung value ng C. Eh, since may distance di ka pa, para makuha, minus D ka. So, makuha mo itong point na to hanggang dito ang length na to. Times 330 kasi yung value ni B, ito, is 330. I do hope na nakikita nyo yung arrowhead dun sa mga figures. No? Equals phi. When we're talking about reduction factor, kapag shearing pa ang pinag-uusapan, based sa NSCP, we will be using 0.75 as a reduction factor. So, 0.75 multiplied by 0.17. The lambda is equivalent to 1, no? Square root ng F prime C, which is 27.5. The BW here is mismong itong length na to. So, equivalent siya kay 3,300. Multiplied by 3,300 times D times 1,000. Okay? Ba't ako naglagay ng 1,000 dito? Yung 1,000 is to convert this KPA, no? I-convert ko itong KPA. Di ba? Kung KPA yan, may go over 1,000 ako dito para maging MPA to. Tama ba? So, nilipat ko na lang yung 1,000 sa kabila para tuloy-tuloy yung equation natin. No? Paki-take note po, itong 1,000 na to is for the, para lang yan sa unit, no? Pag-change ng unit ng kabila. Okay? So, after mo magawa yung equation na yan, so you can use your calculator. Hindi ko na siya isi-simplify, na mag-transpose pa. Ilalagay ko na siya sa calculator. So, we could have 312.213 multiplied by 3,300 minus 400 all over 2 minus the depth. So, kakancel ko na yung 3,300 dito para hindi na siya mahaba kapag nilagay sa calculator. Equals 0.75 times 0.17 times the lambda 1, the square root of 27.5 times 27.5 times 1,000D. So, we could say that the D is equivalent kay 461.5575 mm. So, yan po yung D ng one way. Okay? Then, check for two-way tayo. Two-way shear or the punching shear. Punching shear. Okay. So, same formula. VU is equivalent kay phi. VC tayo. QU area shaded is equivalent kay phi times 0.33. Pakitanda yung formula ha. Lambda, the square root of F prime C, BOD. Okay? Okay. So, I do hope na naintindihan nyo pa to. So, the QU area shaded. So, yung QU natin is pareho pa rin. 312.2130. The area shaded here is ito. Wala pala dyan problem. Ito yung area shaded natin, no? Kung makikita mo, ito yung area shaded. So, we have here, lalagay ko na lang para makita nyo. The area shaded will be 3,300 squared, yung kabuuang area ng pundasyon natin, minus yung ipapunch, no? Yung punch kanina, ito. So, yung ipapunch is, sabi ko kanina, yung dimension ng column plus yung D, no? So, we have here 400 plus D quantity squared. Take note na kapag tayo ay naggagawa ng equation, dapat careful tayo sa mga parentheses na yan, no? Kasi kapag hindi natin nilagyan ng boundaries ang bawat isa, possible, maging iba po yung sagot natin, no? Kaya dapat nagsiset tayo ng boundaries para alam natin na hanggang dyan lang dapat yan, no? Okay. Equals 0.75 multiplied by 0.33 times the lambda, which is 1, times the square root of 27.5 multiplied by BO. The BO is the perimeter of the punch area. So, the perimeter is 4 times the 400 plus D. No? Times D ulit para dun sa thickness. Yung punch area kasi ay ito. So, kung ito yung, drawing ko na lang dito. kung ito yung pundasyon mo, kung yan yung pundasyon mo, tapos, di ba naglagay ng column dito? The possible is magpa-punch. So, yung area kung saan distance half D from the face of the column. So, ito yon. Another. Then, yung masisira kasi, yung masishear dyan is itong nanditong part na yan. So, kailangan yung perimeter, tapos yung itong dimension na yan, no? So, I do hope na nagigets ninyo, no? Okay. D times another 1,000 ulit tayo para dun sa ating pag-convert ng unit. Okay? 312.2130 multiplied by 3,300 squared minus 400 plus D squared equals 0.75 times 0.33 square root ni 27.5 times 4 times 400 plus D times 1,000 D. Okay? So we have here 596. D is equivalent to 596.9514 mm. Okay. So, dito na tayo mamimili, no? Pipiliin natin yung D. Pipiliin natin si D na kung saan ay safe for all, no? So, if we use the D, which is 461.55, so, kaya niyang isurpass yung shearing mo in a one-way shear. But if you use this D, pagdating sa punching, hindi siya pwede, no? But if you use this punching shear, D, which is 596.9514, so, pwede siya sa two-way. Pag nilipat mo siya sa one-way, pwede pa rin kasi mas makapal to kumpara dito, no? Okay, so we will be using this value. Okay? So, to get the thickness of footing is equivalent kay, based dun sa binigay kong definition kanina to, the concrete cover is located 75 mm from the nearest face of the reinforcement steel bars. Okay, the drawing ko lang muna para ma-identify niyo. So, kung ito yung pundasyon natin, so, kung meron tayong steel bar yan, tapos pag ganito, yung 75 mm daw natin is itong nanditong part. 75 mm. But, kung nadaanan nyo to sa reinforced concrete design, no, the effective depth, which is the D, is located from the center of the center ng ng bakal, no? So, ito yon, center nito papunta dito. Ito yung D. Okay? So, we have here yung center ng top bar papunta dun sa natin, we could have this effective depth, no? Okay. So, kung yan yung effective depth natin, so the formula for the thickness, para makuha natin yung thickness, is D plus 1.5 diameter of bar plus 75 mm. No? Okay. So, proceed tayo. I do hope na nag-gets na yung figure na ta. Wait lang. Next problem natin. Okay. So, we could say that the thickness is equivalent kay, dito na lang, equals to 596.9514 plus diameter of bar 1.5, which is 25 mm plus 25 mm, which is itong ditong part na yan ito. Design square footing having 25 mm diameter bar plus 75 mm concrete cover, which is equivalent to 596.9514 plus 1.5 times 25 plus 75. So we have here 709.4514 mm, or say 710 mm. So yung thickness ng mo is 710 mm. Okay? Okay, step 2 pa lang po tayo, no? Let's proceed to step 3. To get the step 3, still requirements naman po siya, no? Parang hindi ka siya. Okay. Next, ano tayo siguro? Next board. Okay. For step 3, still requirement tayo. Okay? So, in getting the still requirements, so, kailangan muna natin computein yung formula, which is mu is equivalent kay phi RU BD squared. mu is QU area shaded times yung critical section length, no? So, balik ko dun sa ano. Ito yan. So, kapag tayo nagko-compute ng mu c squared over 2, no? So, ito yan. Okay? So, lagay ko na lang yung formula na mu is equivalent kay QU c squared over 2. So, QU c squared over 2 times B yan. May B pa dapat yan, no? Or yung distance na tong pag ganon, yung perpendicular distance nito is equivalent kay P RU BD squared. Okay. So, let's lagyan natin yung mga value. So, we all know that the QU is equivalent kay 312.213 times yung C. Ang C natin is from this distance. Ito, this distance, no? So, we have here 3,300 minus 400 all over 2 to get the value of C. No? Then, squared natin divided by 2 times yung B equivalent kay phi. When we're talking about flexure, the phi for flexure or the reduction factor phi is equivalent kay 0.9 naman po. Paki-take note po yan. 0.9 RU times yung B times yung D, which is equivalent kay, ang D natin is 596.9514 squared. Okay. Times, again, ito ay naka APA, MM lahat ng value natin dito, MM din to. So, mag-multiply ka ng 1,000 dito para ma-MPA po yung ano natin. 312.213. Okay, so cancel this B. So, we have here the value of RU, which is equivalent kay, ano ko, kasya pa to. 312.2130 multiplied by 3,300 minus 400 all over 2 squared all over 2 equals 0.9 times alpha x times 596.9514 squared times 1,000. So we have the value of 1.0234 MPa. Okay, so the value of RU will be used in the formula in getting the value of rho. No? Rho is equivalent kay 0.85 F prime C all over Fy multiplied by 1 minus the square root of 1 minus 2 RU over 0.85 F prime C. Kapag sa klase ko, I required my students to familiarize those formulas kasi kapag nagpapa-exam ako, hindi allowed ang index card, no? Pero yun ay face-to-face class, no? Pag nag-online, wala naman akong magagawa kung dyan kayo sa bahay nagsasolve, no? Kung mga opya man kayo dyan. Okay, so balik tayo. So, lagay nyo lang lahat ng value. We have rho, which is equivalent kay 0.85, F prime C, which is 27.5, Fy, which is 275, multiplied by 1 minus 2. Ang RU natin ay 1 minus the square root of 1 minus 2 RU, which is 1.0234, all over 0.85 ng 27.5. So, to get the value of rho is equivalent kay, calculate lang natin, 0.85 times 27.5 all over 275 times 1 minus the square root of 1 minus 2 times 1.0234 all over 0.85 times 27.5. So we have here 0.00381 rho. Then check for rho mean, which is equivalent kay 1.4 over Fy, which is equivalent kay 1.4 divided by 275 is equivalent kay 0.0051. So, mas malaki yung rho minimum natin dun sa rho. So, we will be using this minimum value. Kasi nga, ito yung pinaka-minimum, no? Use. Okay. So, after mo ma-identify si rho mean, so we could get the value of, dito na lang. Atiin ko na lang. Pakakasyahin ko na dito sa last board na to ang solution lahat. Okay, so we have here AS is equivalent kay rho mean BD. So AS is equivalent kay 0.0051 times B, which is 3,300, times D, which is 596.9514. So AS is equivalent kay 0.0051 times 3,300 times 596.9514. So we have here 10,046. 10,046.6921 mm squared. Okay? So to get the value of number of bars is equivalent kay AS over area bar. So we have here AS, which is 10,046.692 mm squared all over divide pi times 25 squared over 4 para makuha yung area ng bar. So number of bars is equivalent kay answer divided by pi times 25 squared over 4. So we have here 20.467. 470 pieces. So say 21 pieces. Hindi po tayo nag-round down, no, kapag number of bars. So round up po usually talaga siya. No? Kasi pag nag-round down ka, ibig sabihin kulang na yung magiging area nun. No? So round up po tayo lahat. Okay? So after getting the number of pieces, so we could get the spacing, no? So spacing, sabi ko kanina sa formula is B minus 150 all over number of bars minus 1, no? So we have here 3,300 minus 1,500, 150 minus 21 minus 1. So spacing is equivalent kay 3,300 minus 150 all over 21 minus 1. So we have here spacing is 157.5 mm. Say 150 mm. Okay? When it comes to spacing po, we could round down, no? Kasi mas mabunbon or mas malapit yung distances niya. Ibig sabihin, mas safe po 'yon, no? Pero wag naman sobrang dikit na, no? So may space pa rin na kayang pumasok ng concrete natin. So, yung 157 natin, i-round down natin to, pwede natin sabihin 155 or 150. No? Sobrang baba naman. 155 mm. No? Kasi usually kapag nasa construction naman tayo, hindi naman tayo naglalagay ng mga point something doon sa actual, no? Alam naman ipa-compute mo pa kay foreman. Okay, pakilagyan po ng 157.5 mm yung spacing ng center to center, no? Okay, so 155 mm on center both ways yan. Both ways. Ibig sabihin, yung pag ganito at yung pag ganito is pareho po ng spacing which is 155. No? I do hope na nasusundan nyo ang haba-haba na sinunod ko. Okay. Saka sana hindi ka naboboring. No? Naiiyak akong mag-joke dito sa sa YouTube. Okay? So, yan po yung Yan po yung problem number 1. So, kung makikita nyo, ito yung recap natin. Ito yung step 3. Ito yung step 2. And this will be your step 1. Okay? So, yun. Sana, naintindihan nyo. Kung hindi nyo man nasundan, i-screenshot nyo na lang siguro sa YouTube yan. Or tapos tanong na lang kayo. No? Okay.